fast does light travel in a sample of water? And we know that the index of refraction for water is 1.33. So imagine my surface here, and I'm showing the water with the blue lines. And imagine I've got a laser beam here with this red line traveling down and hitting that little interface between air, where we know the index of refraction is 1.0, and traveling into water, where it's given that the index of refraction is 1.33. Now, the bigger the index of refraction, the more the light will slow down. So we know that when light slows down, when it crosses from one medium into another, when it slows down, it bends in towards the normal, like that, and the waves actually get closer. So if the wavelength before looks something like this, down in here when it bends, it'll be a shorter wavelength on this side. And because the wavelength is shorter, that means the light is slowing down. Now, we have the speed of light in air, which we just call c, but we'll call it v1 to match the formula. 3.0 times 10 to the 8th. And the goal of this question is to figure out how fast it's actually traveling when it gets into the water, where it's going to slow down by a factor of 1.33. So we're going to use the middle version of our refraction equations. So I've got V1 over V2 is N2 over N1. And we're trying to find V2. So let's multiply both sides by V2 to get it out of the bottom first. And then rewrite our equation. I'm going to put all of this on the left. V2 N2 over N1 equals V1. And then we got to get V2 by itself. So multiply by N1, divide by N2. So I get V1, N1 all over N2. Now V1 was 3 times 10 to the 8th. N1 was air, index of refraction of air, and N2 was the index of refraction for the water. And when we work that through, we get the speed of light in water to slow down to 2.26 times 10 to the 8th meters per second.